PIC24. So from PIC24, yes, I can migrate to other type of microcontroller like STM, this morning we're using Atmel AT89S8253, or even, okay, if you have ESP32, you even can migrate to ESP32. Okay, so you must remember ESP32 is a bit straightforward. We just call the function library PWM. That's it, done. You know, you can generate 30% and 50% duty cycle. So that's the reason I'm not porting it to ESP32 using Arduino. You know, because be frank, you know, it's very straightforward because everything is already written for you. Okay, whereas when you're using PIC18 C compiler or PIC24 C compiler, you are actually design that particular library. Whereas if you use Arduino, you just call the function. So in the end, time to market when you're using Arduino is faster, you know, compared to you're using XC16 or XC8, okay, and etc. Okay, but remember, industry sometimes is not as flexible, you know, as we thought. Okay, sometimes you still need to dive deep into what I call that, writing your own library. Okay. So is everyone? I'm not sure if everyone is here. So let's start the recording. You know, so that those who are missed out this morning, you can watch it. Okay. So okay. Okay. So this morning we are actually solving one of the very interesting tasks. Okay. According to the lab manual, which is we are doing what I call that task 1. We are doing a 50% and 30% duty cycle. Okay, so those who are not in today's lab, is no worry. I will repeat this next week. Okay, those who are joining in this morning, I believe that you already know what is going on. Okay, so this morning we already have any design. You know, we need to have a design requirement and specification. This is a user requirement. As I told you that this is the end user needs. This is a functional requirement, what the system must do. So it means you already meet the customer, you come back over to your team and you discuss with your team. Then this is a system requirement. Okay, what kind of blocks, what kind of special function register might be involved, okay, like timer and interrupt over here. So system specification means we dive a bit deeper. So we know identify what are the input, what are the outputs, and then what kind of time, if you're using timer, what kind of a special function register or what kind of involved, and if you're using interrupt, what types of special function register is involved. Okay, let's say we are using PIC18, okay, or using PIC24. So datasheet is your best friend at that moment to identify what instruction, special function register that are involved. Okay, so then we do a bit of discussions. Okay, then this morning we already identified that we decide to use 10 megahertz and the period is 10 milliseconds. So this is our oscillator frequency. This is our instruction frequency, 2.5 megahertz. So by performing some calculation, then we already write the PIC18 code by using the flow chart that we designed, you know, this morning. All right, now so based on this, any questions with PIC18? Any questions? PIC18? I'm not sharing the slide. Share the desktop. Can you see the slide? Class, can you see the slide? Okay, so this is what we did this morning, and we draw the flow chart, okay, and we do all the necessary calculations, okay. So and then datasheet is your best friend, okay. So then later we also move into from PIC18 we move into PIC24. So the same process, you know, we need to get the appropriate microcontroller, and we are dive into their timer. Okay, so class, the most important thing is you must learn how to look at the block diagram. Okay, So this is very important. Actually, you do not need any reference book. Datasheet is your best friend if you're able to decipher the secret of the datasheet. So we identify the datasheet. I already discussed with you. You're using a comparator. Okay. So and we also dive into the interrupt. Okay, the interrupt vector is a bit different from the pick 18. Okay, this is more straightforward. Okay, it's more easy to use compared to pick 18. Okay. So for your information, the comparator, as I told you this morning, the timer comparator is quite similar to the pick 18. Okay, timer 2. Where's the timer 2? But it's an 8-bit comparison if I'm not mistaken. Where is timer 2? The comparator, you see or not? They're using a same technique in timer 2. Okay, in timer 2 for pick 18. Okay, is it all right? Now, when it's matched, they got set the interrupt service routine. Okay, is it all right? Okay, but if I'm not mistaken, because this is an 8-bit microcontroller, the comparison is just for 8-bit. So if you're using pick 24, it's a 16-bit. So that's the reason we have a 16-bit comparison. Okay, so that leads us, we write the code accordingly, and we write the pick 24 source code over here. All right, so it's quite straightforward. So class, those who attended the lab this morning, any questions? And no worry, I will already created a few videos for this. Okay, so I will post it for all of you, to all of you. So so those who already attended this morning class, any questions that you are encounter, and any questions that that you would like to ask, any problem that you have encountered, and any questions you would like to ask, okay, please post it, now, okay, before we move to the CloudView vision. So any questions from the floor? Why so quiet? None at the moment. Are you sure? Okay. If you do not have questions, let's move on, to the CloudView vision. The CloudView vision is a bit straightforward. Okay. Again, let's begin with CloudView vision. Okay. So as I told you this morning, we need data sheets. Okay. So again, two different things we need to look into in order to generate 50% and 30% duty cycle. We're using a timer and we are using an interrupt. Okay, everything is just based on the flowchart that we have designed. And remember, this flowchart can be used in any microcontroller. Okay, any microcontroller, whether it's the STM, whether it's the Infineon, whether it's a Zilog. Okay, so the same concept is applied. Okay, so same thing. Let's say we are using timer 0, timer 1, or timer 2 in this Atmel. So remember, Atmel is still a very popular microcontroller until nowadays. Is what we call that. This Atmel is considered Atmel AT89S8253. It's been in the market for more than 20 years. So I can say that it's like grandfather of the microcontroller because they're using MCS61 family. Okay, so as I told you earlier, Microchip took over Atmel. So Atmel nowadays is belong to Microchip. Okay, but for your information, MPLAB X is not typed with Atmel. So for all the MCS51 family, they have their own IDE. So one of the most popular IDE is a CloudView Vision. Okay, so we just as usual, we need to identify the nature of the timer by looking at their block diagram. So these are the block diagram. I'll just delete this. Okay, so so if you are using we are not using the 13-bit of counter. We are using 16-bit counter. Mod 1. This one. You are using this. Okay, 16-bit of counter. So by looking at this diagram, things are become very, very straightforward. Okay, so here between counter and timer, if you're using timer, we just select putting this bit to become 0, and this particular bit is under the TMOD register over here as shown here. This is TMOD register, and the TCON register is over here. You see or not? Okay. Okay, not when you set this at the timer, okay, so we are selecting timer. Timer is selecting 0. Okay, it's not 6, it's 12. Okay, so let's say, for example, if I using 12 megahertz of crystal, okay, this is a FOSC. So again, for Atmel is slightly slower. So FCYC actually is 12 megahertz divided by 12, and it gives you 1 megahertz. Okay, so remember, actually the most popular crystal frequency used in Atmel actually is 11.0592 megahertz. So the period is 1.085 microsecond. Why this is important? Because by using this value, they can give you a very accurate baud rate. Okay, very, very accurate baud rate. Okay, so but for testing purpose, I assume that it's 12 megahertz. So it gives you 1 microsecond. Okay, so then that's all. Then we just look at the special function register. TCON and TMOD is very straightforward. Okay, so the TCON itself is divided into 2 sections. So this section basically is just interrupt. Okay, so and we are not using this section, so therefore we don't care about this. This is like a edge triggering, you know, interrupt 0, external interrupt. Basically, it's all external interrupt. What we are interested is just, you know, timer 0, timer 1. Okay, so when overflow occur, timer 0 will be set to 1 if you are selecting timer 0, and this is timer to start the timer, to run the timer. So this is basically TCON register. So only 2 registers involved, you know, in this in accessing timer. So another is the TMOD. Okay, so TMOD is a bit straightforward. Okay, let me delete this. Okay, so again, it's divided into 2 sections. So this is for timer 0. This is for timer 1. Okay, for timer 0, these are the modes. Okay, when this is 0, 0 is a 8-bit mode. Okay, 8 plus 5 is 13 bits. We are not choosing this. We are using 16-bit counter. So this is 16-bit counters. That's the reason we have a 0, 1 here. Okay, so whereas 8-bit auto reload mode means that, you know, you no longer need to reload your value of timer. Means that, let's say if TH0 and TL0 is 1, 2, 3, 4, we no longer need to reload this value when you come to the interrupt service routine. Okay, but however, it's just 8-bit only. So that's why it's not very useful when it's 8-bit, because you create a very large counter value. So that's the reason we still prefer 16-bit of what I call that, 16-bit of timer settings. Okay, so then this one, as I told you, that is a counter or timer. So now we are using timer. It's not a counter. This is 0, and we don't care about the gate. All these things we don't care. So basically, TMOD is just equivalent to 0, 1. So it's quite straightforward, isn't it? Okay, it's quite straightforward. Okay, so if all this thing is done, then we look into the interrupt. Okay, we're back to the interrupt. So as I told you just now, you know, this morning, interrupt is even straightforward for this particular microcontroller. Okay, so basically we are to enable the interrupt, you just enable the master interrupt EA equal to 1. So this is quite similar to GIE in PIC 18. Okay, so and we need to enable the interrupt interrupt timer 0. This is the ET0, and ET0 is for the timer 0 interrupt. Basically, we just enable this bit and this bit, okay, for initialization purpose. Okay, this is for interrupt priority, so we don't care about, for the moment, we don't care about who comes first, okay, the priority. So, and then I think basically that's all. And as well, still remember this morning when we write our program in pig 18, let's come back to the program. In pig 18, the initialization for the interrupt, it should be like this. Okay, low priority. Okay, automatically they know that timer is already set. Whether it's low priority, is high priority. Okay, when you come to pig 24, you have to refer to the table. So these are the reserved timer 1, timer 2, timer 0, OC1, OC2. And these are the standard that you should apply. Okay, still remember, auto PSV is normally not recommended if you don't have a constant declaration inside your interrupt service routine. Okay, so but then you should put no PSV. Okay, no PSV. Is it no PSV? Okay, no PSV. Okay, is it okay, class? Okay. So how do you know that whether it's auto PSV, no PSV? I don't know how to write the appropriate function call for the interrupt service routine. Again, then you need to get the reference manual of user manual, XC8 or XC16 user manual. Where is it? Where is the user manual? This is a user manual. Then let's see, I always go to the interrupt and auto PSV. Okay, if you don't have PSV, no auto PSV. Okay, that's why just now I create error. Copy this. Come back to your file. Come back to your MPLAB X and just put no auto PSV. Okay, is it okay so far, class? Okay, class, you should try this at home. You just can't listen to me. Okay, so it's very difficult because you don't have enough time for you to do a lot of practice. So be frank with you, actually this embedded system design, I've been fighting for so many years, want to convert this from full lecture, from exam oriented to become, what I call that, to a full coursework base, okay, like object oriented, like what Dr. Lai did, but I don't know why every year my fight is not good enough, okay, so every time it's being turned down. Okay, Utah still want you guys to go for exam. Okay. So, okay, never mind. Just come back to this. Okay. So once you get this thing done, then you can start writing your code. So remember this morning, I just copy and paste this. Okay. Okay. The only thing I make a mistake this morning is just like, for example, this one, the define. Okay, so this is only C programming apply for pig 18 and pig 24. So for CalU Vision, we are using S bit, is single bit. You see, my single bit duty cycle port 1 bit 0. So this means that port 1 bit 0 will give you the signal of 50% duty cycle. Port 1 bit 1 is the 30% of duty cycle. Class, remember. So I'm using this. This is to accessing a bit, port 1 bit 0. Okay. Whereas for microchip, it's a bit different. Microchip, we are accessing LATB latch 7 or latch 8. Okay. Because the internal architecture is a bit different. Is it all right, class? Okay. So this means that when you migrate to the new microcontroller, some fundamental C programming for that particular microcontroller you need to identify as well. So all these things is identified through the microcontroller's C compiler manual. Okay, like for example, let's say for this one I need the XC8 or XC16 user manual. Okay, is it all right? So in the end, you need to do a lot of reading. Okay, this one is very straightforward. Okay, like example, I just register, I right click, I can include the library. Like for example, now I can accessing the library, you know, this is the library, a special function register, they all declare to the register. So this microcontroller is not as complicated as what? As the beloved microchip PIC24 or PIC18. So as usual, I do the initialization. I call the function initialization. So here I set the overflow bit. I set the timer 0 and timer 0 value FC18. Tmod is 0x01. Enable the external interrupt, timer interrupt. Enable the master interrupt. Timer will start running. So it's very straightforward, basically. Okay. So you might ask why FC18. Okay. Here is the reason why is FC18. Oops. And here's why the reason is FC18. Okay, because we are using 12 megahertz. Yeah, by 12, if 1 microsecond, correct or not? Okay, so this means that it's 16-bit. Okay, so again is 65536 minus x multiplied by 1 microsecond should give you about 1 millisecond. Why? Because every interrupt every 1 millisecond he interrupt, it will be activate the interrupt. Okay, so I hope that this morning class you know. So x should be about you calculate is about what's the value this morning we calculated, correct? Is 4,000. Should be 4,000 64536. Okay, 4,000. X should be 4,000. X should be 4,000. No. This should give you. Okay, correct. Yeah. Okay. You just calculate, then x in the value it should be 461. After you do calculation, it should be 64536. Okay, and 64536 is equivalent to 0xFC18 in hexa value. Okay, is it all right, class? This is what we did this morning, correct? So that's the reason we are using FC18. Okay, so those who are just joining, okay, you just try your best to understand because we repeat this next week. Okay, so same, then FC18 means you generate 1 millisecond. So every 1 millisecond you come into this interrupt and reload the value. Okay, reload the value. Okay, reload the value. So count plus plus. Every 3 millisecond I toggle. Every 5 millisecond I toggle. So this is to create a 30% duty cycle. This is to create 50% duty cycle. So this is to reset the counter and repeat the process. Okay. So is it clear? So if clear, it give me a thumbs up for those who already attended my class this morning. Is it okay? I'm not sure, none at the moment. I should have 19 of you. Okay, please try, okay, those who attended my class this morning. It's very straightforward. It's very easy, actually. It's nothing tough here. Okay, now it's come to debugging. Okay, so we compile this. Now, why I love CalU Vision? Because what? Because it's just very fast and very smooth and very user friendly compared to microchip. Still remember this morning, I don't know, I keep on failing to get my logic analyzer functioning. I also don't know why it's not working. If you're able to find out the reason, let me know. Okay, this is nothing to do with my program. Still remember, I port it to my Proteus. It's worked perfectly all right. Okay, so this is the same program. Let's compile this. Okay, any questions? Okay, let's compile this. Compile this. So it worked perfectly all right. Okay, so and of course, since we're using 12 megahertz, we have to ensure that 12 mega go to target. Make sure that it's 12 megahertz being set. Okay. Okay. So then we press the debug here. I press the debug. Okay, this is the limitation of using free copy lah. 2K is more than enough. Okay, the debug, this is coming out. Okay, let's close this first. Okay, so these are the assembly code. This is the C code that you write. This is the disassembly value. Okay, everything is the same. So let's say, for example, remember the layout of MPLAB X and CalUvision definitely is a bit different. This one is so interesting. So I got peripheral, I can open the input output. Let's say I'm using port 1, I can using the port 1. You can toggle itself, you know. So everything, let's say timer, I can see all the timer. Just click on it. It's so easy. So this means that if whatever displayed over here is tied with the microcontroller that you are using. Okay, it's very, very user friendly. Okay, so let's say, for example, you go to debug. Okay, you want to look at okay, okay, let's go to come to here. View, analysis, logic analyzer. Okay, we put the logic analyzer here. Okay, put the logic analyzer here. So I put a setup. Okay, so let me delete this. So we are using port 1.0. Okay, remember the style, port 1.0, 1.0. Okay, okay, done. So port 1.0, it should be not an analog, it should be a bit by bit mark. All right. Okay, I give him a color. Okay, I like blue, I like red. Okay, red. Okay, put red. Okay, then port 1.1. Okay, then okay, what color you want for port 1.1? Okay, you want pink, I don't know. You want orange color, is up to you. Okay, looks nice. Okay, then that's done. Okay, then I say close. That's all. Okay, so and this thing is very user friendly. You see the thing down here? This is, I reset my stopwatch. They got 2 stopwatch down here. Okay, I can monitor the time, you know, in second. Like for example, so every time I come into here, it should be 1 millisecond. I just put a breakpoint here. Okay, it should be about 1 millisecond. Okay, let's try. Let's try. I run it. This is run. Come inside here. 0.01 second is 1 millisecond. So, and you see the graph already 1. Okay, so and then I put the duty cycle here. It should give me 3 millisecond. 2 plus 1, 3 millisecond. Correct? So we come to here, it's about, come back here. Okay. Because I remove this first. I remove this. Okay, it should be 5 millisecond. Correct or not? Because this duty cycle. Okay. So if I come to here, it should give me 10 millisecond. 10 millisecond. Okay. So now port 1, just now I forget to set because it's still analog. It should be a bit. Okay, come back over here. So it should be a bit. Okay, close. Okay, bit. See the toggle already, 30% and 50%. Okay, let's I run it now, one by one. You see or not? 30% duty cycle is already generated. Okay, so I stop this and I can run it nicely. You see, it's coming out. I can make it smaller, larger. I can pause it. I can analyze the time. You know, I click here. They already show me, give me some information. I put the mouse here. Okay, I put it over here. They already informed to me what is the frequency. You know, look at the delta frequency. What is the time and up to down, 0 to 1, 1 and 0. So it's a lot of things you can play around with these particular things. And so smooth and so user friendly. Okay, is it okay, class? So it's not difficult at all. So okay, is it okay? I will post this code. You know, it's those who want to copy. Okay, so I will post it over here in the chat box over here, so you can copy it, so you can use it next week as well. Okay, so let's come back to here. Come here, so you may try it if you want. Okay, try it during this weekend. Okay, so class, any questions you would like to ask before you move things? We want to move forward. Okay, any questions so far? Any questions? Okay, so like for example, one more things, like for example, if you want to port this to my Proteus, same, you can just open the option. So make sure that the output is generated to the hex code. Okay, you generate the hex code. So hex code will be generated when you compile this file. When you compile this file, hex code is shown over here. You see, hex code is creating at this particular directory, and how many code size that have been used is 238 bytes on etc. Okay, so same with your MPLAB X. Just now, whenever you compile any file, let's say this 50%, 30% to this cycle, when you compile any file, okay, all the information is shown over here. How many data memory is used, how many program code have been used. Okay, so this is a bit slow. You see, it's quite slow. I tell you that because the way of the developer develop this MPLAB X, okay, is a bit slow. Okay, so how many bytes is being used? It's about 1%. Okay, data memory. All the information here is quite important. Okay, this way. Okay, is it all right, class? Okay, so like for example, you can always port to you always can port to this Proteus. You see, even though I got mail as well, if I'm not mistaken. Okay, just close this, go back to UIP, let's say 80 9. Yes. Okay, they got I don't think so they got this library, but all these things can be downloaded through from the website, from the respective Proteus website. Okay, is it all right? Okay, now you can component search engine, you can press and view and search it. Okay, for more library. Okay, is it all right? Okay, class, any questions so far? So this means that it's not difficult for you to port, from one design to another design. Okay, is it all right? Yes. So any questions? Okay, let's make things interesting, more interesting. We try to put in a switch. Okay. So any questions with what I call that in this for this micro U vision? It's very straightforward. Okay. So I can see port 1 is blinking as well, toggling. If by putting this thing here, put a breakpoint here, you see toggling. You see port 1.0 is toggling. See, toggling by 30% and 50%. Okay, it's toggling here. Is it okay, class? So it's quite straightforward and quite very user friendly. Okay, so before we're moving into back to this MPLAB X, why I say this micro U visions is very popular. Let's have a look. I create a new project example. I create a Chincai test. Okay. Just have a look. These are all the manufacturer can be supported by CalU Vision. Okay, not mentioning about they are supporting all the ARM microcontroller. Okay, just say example. I never heard about Core River. Okay, they got all these Core, all these things. It's still using X051 microcontroller. It's still very popular. Daewoo is Korean. Okay, it's still in the market. I'm not sure. Okay, Daewoo is those days they produce a lot of radio, Walkman those days. If you still know what is Walkman, my time is very popular. So Honeywell, you see, Hyundai, see all the microcontroller. Okay, Maxim, it can support a lot. Okay, a lot. Any microcontroller in MCS61 family can be supported by MCS51 and support all the MCS51 family. And one more thing I want to say is how about the ARM microcontroller? I believe that I also asked you to install the MDK51. Okay, once you install the MDK51, you go to CloudView Vision 5. This is recorded. No worry, you can come back to this. Go to UV4, then you can click the pack installer. Okay, let it load. Okay, so this one is to download all the microcontroller, which is all the ARM microcontroller in the market. The board, let's say for example, I still remember I show you, this board last week. This is a very powerful and very powerful board. Okay, this one, let me show you again. Can you see this board? The nuclear board. Okay, let's say for example, I want this to be supported in my CloudView Vision. Okay, so if you want this to be supported in the CloudView Vision, then you have to look for that particular board. Okay, STM. You see so many board you can support it. Like for example, nuclear board, STM. Okay, STM microcontroller. This all the STM microcontroller. Let's say I want to support nuclear. You see all the nuclear board. Okay, this is all nuclear board. This is the board that I'm using now. So this is the devices, the microcontroller in that particular board. So I can install all the related library. Okay, so that I can download all my code into this development board. Okay, so you can develop everything using CloudVision and download the development board. So even the devices that you use, just imagine how many devices can be supported by this CloudView Vision. Okay, let's say Infineon, I got all this microcontroller is ARM microcontroller. You see Cortex M0, okay, Cortex M4. It's too many, more than thousands over here. Of course, you need to install it if you want to use that particular microcontroller. You see or not? There's too many. It's too many. Okay, from A to Z. Okay, from A to Z, from A to Z. So this means that you see, like it support about 7,000 over devices over here. Okay, so that's the reason I prefer CloudView Vision, but based on the statistic, microchip do very well in marketing. So that's why, and some more microchip is free if you don't need the optimization. But however, this one is not free. That limits the code size. Okay, like for example, like MCS51, they limit 2K. If exceeded 2K, it will not functioning well. Okay, so but 2K for student is perfectly all right. I think it's 4K for ARM microcontroller. Okay, this is just to share with all of you. Okay, I hope that you know. It's not difficult actually. Okay, it's not difficult. So once you install this ARM microcontroller, you can you try to install it. Definitely, you can see what I taught you last week. This one. Okay, still remember towards the end we have arrow pointer. Where's the arrow? Under the structure. So you will definitely seeing all this GPROC model. Okay, actually this is I copy and paste from the STM32F4 microcontroller. Okay, so if you have time, we will go through this again. Okay, to show all these things in the CloudView Vision. Okay, so is any questions so far, class? Am I talking? Am I overload you guys? Okay. Yes, let me know. We are very democratic. So any questions so far? Yes. If no question, give me a thumbs up. I'm not sure whether you will appreciate all this or not. Okay. Yes, any questions? And class, remember, CloudView Vision is not in our syllabus. Okay. This is the additional things. Okay. So any questions? Okay, if no, then we have something more interesting. before we move to our lecture after this. Okay, let's say for example we come back to the MPLAB X. Since you already designed these beautiful things down here. Okay, so let's activate the switch. Okay, let's activate the switch. Okay, let's activate the switch. Okay, let's instead RD0 we do RA0. Okay, why I want to use RA0? Because this one is touching the analog digital pin. Alright, we're sharing. You see, RA0. Come back over here. Pick 18. You look at the device itself. RA0. Yeah, RA0 is sharing the analog pin. So what I tell you this morning, when you're sharing analog pin, you have to be careful. By default, this AN0 is set as analog, but now we are doing everything in digital. So therefore, we need to set this particular pin to become a digital. You need to inform the microcontroller such that this pin is set as a digital and it's not an analog. So how to do it? Again, we have to come back to this beautiful bookmark, and we have to come to the analog digital converter. There's so many things over here. Where's ADC? It's so complicated. Where's ADC? Why I can't see ADC? Here. Okay. So ADC definitely is this ADCON 0. Okay. So set the, is it ADCON 0? Not ADCON 0. It should be ADCON 1 or ADCON 1. By default, it's all 0, 0, 0. Okay. So it's all 0 means that it's all analog. So if I want to make one thing digital, then I should set this particular bit to become a digital. Okay, AN0. Okay, so I can set if I want to set this digital. Okay, so it's quite straightforward. I just put 0x0f lah. So F1, 2, 3, 4 means this 4 pin I set as digital. The remaining pin I set as the analog. Okay, so this means in my main program. Okay, so initialization here, I just put additional line. I just say, what I call that, ADCON 1 is equivalent to 0x0f. Okay, it's ADCON 1, is it? Okay, never mind, we just compile. Is this, not this one, not this one, this is big. 24, sorry, so I'm using this one. Okay, sorry, this one. There's too many files here. Okay, initialization. Let's put this ADCON 1. Okay, now there's no error. Okay, this ADCON 1 is 0x0f. So switch is RA0. Okay, switch is RA0. Okay. So what I'm going to do this, okay, well, okay, probably you can write additional things here. Okay, like for example, while switch equal to 1, then do nothing. Okay, and when switch is high, we do nothing. When switch is low, then only we can activate the things. Okay, let's compile this. Why got error? Okay, doesn't matter. Okay, it can be, it's depreciate only. Okay, so this is which file? Duty 5030. 5030. Okay, so we compile this, correct or not? 30, 50, 30. Okay, so probably then we directly go to the Proteus. Make sure that is the correct file. Is it 30, 50, 30? Okay, where is the file? I hope it's correct lah. So by right, when I run this, it shouldn't run. Okay. Yeah, it shouldn't run. What happened? Again, okay. Let's come back to the MPLAB X. So here is the load, where is the COF file? Okay, hold on. So to ensure the COF file is really created. Okay, yes, it's created. Okay, so where is the COF file? Okay, now we come to here, we load the file. Okay, and we are going to the, I install these things under download pre-lab. Okay, date. Okay, I think is this the one? It's here, is it? Yes, this is 1452. Yes, open. Okay, run it. Okay, see, still blinking. One first. Oh, now we draw out everything first. Okay. We come back over here. If switch equal to 1, it's do nothing. Okay, let's draw the switch first. So this is linking to RA0. Okay, so we need a push button. Okay, we need a push button. Okay, then we give him a resistor, 330 ohm. Okay, any 330 we do. Okay, the big one, the small one. Okay, anything lah. Okay, 33 ohm. Okay, any actually this is just a value. Okay, 330 ohm. Okay, so that's all. Okay, so we pull out the buttons. Okay, so this one you link over here. We take out the ground. Okay, so we give him a power, not is full to high. Okay, we put what I call that, LED, what I call that, the resistor. Okay, so link the resistor. Okay, so you put to high. So if you don't press the button, it won't run. Correct or not? Okay, probably if you want to play with the LED, you just take out and probably will not get the LED green color or any color, LED red. And you got LED red or not? Okay, oh no. If some, okay, this is animated one. Okay, better. Okay, let's connect an LED over here. Okay. Here we connect to the resistor. Let's say give him 33 ohm lah. So connect over here. Connect over here. Give him a ground. Where's the ground? Okay, let's run it. Will you blink? It wouldn't blink, correct or not? It blink, man. It blink. How come? Anything I miss out in my program? Let's go and have a look. Of the interrupt, it should be happen before the interrupt. Okay, it's already running, correct or not? It's already running because my program is before the interrupt. Correct or not? So I should do this before anything. Correct. I cut this. I initialize the I/O. Did I set the I/O input? I don't even set this as an input as well. Okay, tries A0 should be an input. Okay, tries A0 is an input. Okay, so I initialize this. I initialize this. Okay, start the timer. Timer is run. You can jump into the interrupt service routine by itself. So probably I do it over here. Then things will be different. By right, shouldn't be run. Shouldn't be running. Okay, and you no need to worry about reload the COF file into that particular microcontroller again because it's already auto reload. Okay, let's run this again. I don't know how to light up, so I need to press this. Now then only light up, correct or not? Then only blink. Then only my oscilloscope is showing value. See or not? Okay, then only blinking. So I reset this again. Okay, so I run this again. Okay, so these are the code. Okay, so I'm hang over here. I cannot run You see, I run already. You see, give me error a message. Pause because of this. Keep on running. You see, if you run. Okay, so I pause the thing. You see, it keep on hanging over here. Keep on hanging at that particular place. Switch. Okay, so I run it. It won't run. Nothing is display. Why? I press anything. There's nothing here. Why LED is blinking? When I press this, then this thing is coming out. Okay, my LED. The LED is okay. Is it all right, class? Okay. My LED is blinking just now. Okay, you play around with it. Okay. Is it all right? Like for example, it's nothing. It's not running at all. Okay, it's not running at all. Okay. Press this. Okay. Let's run this again. Nothing here. Nothing is displayed. Why our LED is running? Okay. Why? Okay. Initial I/O is already running. Okay. Yeah, I didn't even control the LED, correct or not? Okay, I haven't controlled. I mean the duty cycle initialize. Right here, it shouldn't be interrupted. Okay, you can debug the program and see what is happening. Okay, class, is it okay? So you can try to play around with this. It's running. You see, it's not running. So I press this. Then only it happening. This running. I don't know why. Is something wrong with the simulation or what? Okay, not class. Okay, so this is a very simple design, of PIC 18, with the microcontroller. So same, you also can draw this, for PIC 24. It's very straightforward for PIC 24. So same project. Let's say we use one for PIC 24. Okay. Let's say we browse. You go back to my download. Okay, to my pre-lab. Okay, this is for PIC 24. Okay, select. Okay, so close the project. File new project. Okay, select folder. So PIC 24. Okay, next. Finish. Okay, so same, we just use PIC 24 FJ 64 GA002. This is the one. PIC 24 FJ 64 GA002. Okay, so we can take out the microcontroller here. These are the microcontroller. You can reload the COF file. Okay, it's PIC 24 here duty cycle. Okay, it's under here, correct? No, it's here. What the heck, Scott? I didn't generate the COF file. Okay, so again, you can come back to the microcontroller here. Okay, and then you can using a PIC 24 set this as a main program. Okay, this is the PIC 24. So let's say we don't need the switch. Okay, so we make sure that we generate the COF file. Okay, so then we compile this, so the COF file will be generated. Then you just come back over here and select this PIC 24. It's 5 o'clock already, so we have to move. So class, don't worry, those who haven't attended this morning class. So we'll repeat all this, next week. No worry. Okay. So okay, then we need to do a bit of drawing of this PIC 24. Okay. So by right, what I call that? This PIC 24 need to have a bit of what I call that setting, Okay. So by referring to the data sheets, we need to have the master clear, all these things. So for the appropriate connections, these are the value that you need to put in. For PIC 24 is up to you. So let's say I need a 10K resistor. Okay, so 10K resistor. Okay, any 10K will do. Okay, just select one. Okay, 10K resistor, and we need about 100 nanofarad capacitor. This is a way of connecting, proper way to connecting the microcontroller for PIC 24 microcontroller. And probably I need 0.1 picofarad. Some time. Okay, there's so many 0.1 picofarad. Okay, I just simply choose one. Okay, just simply okay. Why got problem? Or this one need to be import. Okay, doesn't matter. I can choose any microcontroller, any you do. It doesn't matter. It's just a drawing only. Okay, so again, we just need to we need a resistor. This is a 100K resistor. Okay, this is a proper way of connecting. So although you can just directly using what I call that, using just put it to high, like what it did for the PIC 18. Okay, so but I don't want to do that. So that's why we want to do it more professional, because you are always using PIC 24 later. We label it nicely. Okay, so for example, this one we have to set it like, for example, this is a VCC. Okay, set it to VCC. Okay, so they can label it nicely. This is go to the master clear. Okay, then we come back to the component. We need we need a capacitor. Okay, and then we need a ground. And we need another capacitor. Okay, so we link this over here, link this over here. Okay, so the DIS DERG is the internal voltage regulations. Okay, so we normally connect over here. Okay, so this capacitor connect over here. So this is to do a internal VDD core so that they can generate appropriate voltage for the microcontroller. Okay, but this actually it should be 0.1 picofarad. It's just a label because of from Proteus they don't know the electrical characteristics. Okay, so then I think that's all. Then we have moved into the MPLAB X again. So this one we are using RB7 and RB8. Okay, you can RB7 and RB8. You can use oscilloscope again. You can connect to RB7. You can connect to RB8. Okay, and run the program. See, the signal is already generated for you. Okay, is it okay, class? Okay, 30% and 50% of duty cycle. Okay, I think something wrong with my crack. I think when this is coming out means it's something, my crack is not very good. Okay, run this again. Okay, so 30% and 50% duty cycle is generated. Okay, is it okay, class? Already I hit 10 minutes. So I will give you all these file from everything to all of you so they can try during this weekend. Those who haven't attended my this morning class, you can try as well this weekend. We can, so that's next Thursday will be more familiar, correct? Will be faster. Okay, so sorry about all these things, drag your time. Okay, so I will show you some of the video. This is the video that I recorded last round. Okay, let's have a look of some of the video. 2019. Okay, there's so many. Let's say, like this one is using the code configurator. I also already solved the dual tone for all of you. Okay, so like this big 24, you know, and I run this video. This one is no sound because I recorded quite some time already. I just typing, you know, I just type because my voice is not as good as I don't have a sexy voice. So this is the old way. They say I'm running this, you know, explaining all these things over here in details. While the 4000, everything is here, and then once I generate, you know, I generate the what I call that, the duty cycle. Still remember the logic analyzer. So I select a channel. I write it come out perfectly, you know, because last time I'm using the older version of 8.90. Even the newer version don't have any problem last year, you know, with, when I conducted this together with your senior. Okay, and by right, when you run it, it should be come out with where is it? Nothing. You see duty cycle is coming out. You see or not? Just now you can see. Yeah. Okay, there's some duty cycle is coming out. Okay, so you can watch this. Okay, movie as well, and then you can watch this code configurator. Okay, code configurator is very easy. You know, again, code configurator is for those who are already expert, you know, in initialization process. So these are the video. Okay, and there are also some the Proteus for MPLAB X. This one is basically I direct you directly, you know, using what I call that, using Proteus, you know, directly compile from MPLAB X. Okay, So I'm not sure. I also don't know why this round of MPLabX is not functioning, it's not working. Okay, so we rest for a while. We have a break of 5 minutes. Okay, while at the same time, let me know if you've got any questions. Is it okay? Is everything okay? Give me a thumbs up. I'm not sure whether you guys I give you too many things today. And I also should welcome a new student. There's 2 new students with us. Okay, I just checked the attendance list. And 2 left us. MS student, I think 2 I think MS student left us because probably for the past 2 weeks it's very heavy, you know. I also don't know why. Okay, but I don't know why these 2 students join in as well. Okay, they will be very stressful, you know, with this subject. I hope so, no? Okay. So we tentatively stop the recording. We resume it later after 5 minutes. So let's have the clock. Five minutes. Why cannot change? Hello, everyone is back. If everyone is back, give me a thumbs up. Okay, great. Okay, only 3. Okay, so before we look into chapter 3, okay, so start from chapter 3 is all more technical things will be involved. We are really dive into PIC24 architecture. We also dive into ESP32 architecture. Okay, we'll go deep, into PIC24. Okay, so class, remember, my mission here is not to teach PIC microcontroller. So that's the reason I will open the door, to different type of microcontroller, because this is embedded system design. You must have a capability to choose the right microcontroller for your final year, not for your project, for your product, for your product design in future. Okay, so let's look in. Before I look into the lecture 3, let's dive into this lab. Okay, so class, basically you do not need to submit task 1. Okay, so task 1, actually you got a 50% and 30% duty cycle. Basically I already did this for you. Okay, so, and the second one, actually you do not need to submit. Basically this one is to doing a dual tone. Okay, I will give you the answer. So if you are hardworking, you should try it, at home. Okay, basically the dual tone is something like this. Okay, you dual tone, 2 different frequency. Okay, dual tone. This is always used in your dial pad of your telephone. Okay, so this is 400 Hertz for 500 millisecond. So this basically is 2.5 millisecond. So means that here is 1.25 millisecond. Okay, so basically you want to generate this, into one of the any microcontroller. The output should give you this. Okay, this is a dual tone. So dual tone is very useful. There's a lot of benefits, for dual tone. Okay, so task 1. So basically these 2 you do not need to submit. So actually task 2 is the one I want you to do. Okay, so it's up to you whether you are work alone, individual, or probably you can get a partner. Okay, 2 in a group. Okay, so when 2 in a group is a bit tough. That's what I think, because it's a quite distance. 2 of you is quite distant, unless you have a proper discussion among yourself. I don't want such that, you point finger each other. He's didn't do things. I'm doing do things. You come back and complain to me. Okay, I don't want this to be happened. And for your information, it happened almost every year in the subject embedded system design. Okay. So that's the reason I give you option. If you think that your friend is not a good friend, don't work in group, work as an individual. But of course, I prefer work in group, because this is a group work. Okay, so let's discuss about this task 2. Okay, so okay, look at here. We are construct the PIC24 and class. Remember, this one is optional. So because now we do not have a lab, we don't have a PIC24 FJ64 GS002, you can using just Portios for simulation purpose. Okay, option 1. Option 2, if you are the challenging one, and actually it's not so tough. Basically, if you can directly using your ESP32 development board, to develop this. Okay, although I didn't teach you, but I believe that there's a lot of informations out there. So you can using ESP32 to perform to carry on this task 2. Okay. So first of all, let's look at the requirements, the fundamental requirement for task 2. There are 2 push button, switch 1 and switch 2. They got 3 LED, LED 1, LED 2, and LED 3. least look at the requirement clearly, okay? Because you, in your report, you're going to write these 4 items. You need to have a user requirement, functional requirement, system requirement, and system specifications, okay? So if possible, I prefer there's a flow chart in your writings, okay? Okay, so let's come back to these questions. There are 3 LED, LED 1, 2, and 3. Okay, a variable voltage input at one of the analog input of the microcontroller. So you have a variable resistor, variable input. You can create this voltage using a variable resistor of 10 kilo ohm and connect to VDD and ground, like as in the figure 1. Okay, something like that. Okay, so they got analog input. Okay, so LED 3 will always blink at 1 Hertz. So means LED 3 by itself is blink at 1 Hertz. When the system first starts, LED 1 and LED 2 are off. But LED 3 is already start blinking at 1 Hertz. So I hope this thing is very clear. So for switch 1 and LED 1, when switch 1 is first pressed, LED 1 will start to blink at a preset rate. Okay, what are the rate is all up to you. So it's something like this. This is the LED 1. I press. Every time I press, different frequency will be generated. Okay, so this means that the blinking rate of the LED will be changed accordingly according to the times that I press the LED. So first time I press, remember it's a push button, it's not the sliding type. When I press, I release, different frequency. When I press again and release, different frequency. When I press and release, then a different frequency. I press and release, then a different frequency. So remember, push button, they always have something called a debouncing error. Okay, so I hope that you're able to explain in the debouncing error. But the good thing is, in simulation, we can't see the debouncing. So in real hardware, real world, you will see the debouncing. But although you can't simulate the debouncing problem in the project simulation, I want you, to explain this. Or what I mean is, you should have a debouncing. You should solve the debouncing problem in your code. Okay, what is debouncing? I believe most of you know this is a push button. When you press the push button, normally they have some time before it's stable down. When you release also, you've got some time before it's going up. So these are the debouncing. Okay, it's about 20 to 25 milliseconds. It depends on the structure of the mechanical switch. Okay, so because microcontroller is very fast, microcontroller might detect high, low, high, low, high, low. Okay, for you, it doesn't matter. You press and release, you don't see anything. Okay, but for microcontroller, it might detect this, what you call this, a debouncing problem. Okay. Then of course, the final LED. Okay, switch 1. So switch 2 and LED. When switch 2 is press and hold, switch 2 we press and hold, the LED is blink according to the rate of the analog input. Okay, because this is analog to digital conversion, so we hold it, then this particular LED we change, the blinking rate is changed according to the analog input. Okay, is it all right? So they got 3 sections here. These 3 sections are independent one another, so they are not crossover. Blinking LED 1 is LED 1, LED 2 is LED 2, LED 3 is LED 3. They are not independent one another. No, the answer is no. They're not independent of one another. Here are the simple flow chart I given to you. They got 3 sections here, 3 modules. This is a very fundamental flow chart. Okay, so for module 1, press and release, blinking, press and release, blinking, press and release, blinking. Okay, for module 2, to press and hold, we read the value from the analog analog input. Okay, Then when you release, you just go off. Okay. So module 3, you just blink as usual 1 Hz. Okay, is it all right? Okay. So if this is all right, then these are the assignment outcome. And the deliverable, you should work in the Proteus as demo. Okay, you can submit your soft copy. I will conduct an individual Q&A session. So the deadline of soft copy is 18th of July for P2, 25th of July for P3. Okay, the time is negotiable, but I hope everything is on time, because still remember, when we study embedded system, time to market is very important. You cannot delay. So whatever you have, everything has to be submitted in to this link. Okay. So now, any questions from the floor? What is delay 100 milliseconds? What do you mean? Kai Chin? Where is 100 milliseconds? Yes, Kai Chin, I don't understand what you mean. Okay, I think the bouncing is 20 to 30 milliseconds plus and minus. Okay, that will do. Okay. So any questions? Is this assignment you say is tough? Is not very tough. You say it's easy. It's not very easy. So I make things easy. I prefer no interrupt. No interrupt involved. If you are good, you can use enumerate. If you're super good, then you got a structure, you got a pointer. That will be a tougher. I'm reinforce you to do all these things, but no interrupt. Okay, because I don't want your 3 interrupts here. So is it necessary to have interrupt? Okay, because might be interrupt might solve the debouncing. I'm not sure. Okay, so you have to come up with your idea. Okay, you may discuss among your friends. Okay, so whether it's individual work or the 2 in a group works. Okay, this is basically your main assignment. You need to submit this. Okay, what I need from you is this: a cover page, a user requirement, function requirement, system requirement, system specification. I prefer there's flowchart. I put an option here, so I still prefer the flowchart. So schematic diagram in Proteus, code with a comment and a bit of conclusion. Then I will conduct a Viva. I will ask you a questions, regarding to your design. Okay. So how the marks is given is over here. These are the marking scheme. Okay, so it's the individual assess. Okay, it's a marking scheme. And the maximum marks is 10. I can't remember what is the marks for the assessment lab 1. I need to check back. I already discussed with you in the lecture 1. Okay, this is basically for lab 1. So any questions you would like to ask, again, I open this, whether you're using ESP32, okay, hardware. If you're using ESP32 hardware, you do not need Proteus, or you just do everything in Proteus. I believe that a lot of people will choose Proteus. Okay, why? Because Proteus, you can't even simulate, what I call that, debouncing problem. 2 switch press at one time, 3 switch press at one time. Okay, but I will change this to the sliding switch. I want to make sure if 3 switch press at one time, what will be happening. Okay, when I release 1 and release 2, what will be happening? There's a lot of unusual situation that occur, even though it's just a push button switch. Okay, is it all right? Okay, even though I haven't teach analog digital converter, so I hope that you can explore yourself, and I try my best to start analog digital converter as well. Okay, so this is basically your assignment 1, your lab 1 that you need to submit. Okay, so you do not need to submit for task 1. You don't need to write any reports. So basically, task 1 is for you to familiarize different type of tools, and you're not necessarily using PIC24, AJ64, GS002. You can choose Atmel as well. I'm fine. 8089S8252, 8253 is perfectly all right. Okay. So now, any questions from the floor that you are not sure? If you're okay, give me a thumbs up. If you think it's difficult, you just type difficult. Okay, or Yong En say it's very easy. Proteus got, sorry, Ying Hao, no, we don't have ESP32 simulations, you know, in Proteus. That is a problem, you know. Probably you go to the Proteus website and check whether they already created a library, you know, for ESP32 or not. The time that I tried, there's no such library. Okay. So class, whatever you design here, you don't remove it, and then we move on to the lab 2. So lab 2 is very easy. It's nothing, you know, we are learning Proteus. You're already expert now. Okay, and you are basically, you create a 3-dimensional PCB to Proteus. This one is always straightforward. Okay, and then you connect with the LCD and keypad and analog digital converter. So that's the reason I will move this up earlier, the ADC, you know, as one of the tutorial section. In one of the tutorial section, this is the analog digital converter exercise. Okay, so then lab 3. So lab 3, basically we are learning micro COS2 for PIC24. ESP32, we are using FreeRTOS. This is for PIC. So we no longer touching ESP8266. This is the last year experiment node. We don't do this. Okay, yes. Okay, ESP32, we are using FreeRTOS. Okay, so basically, the assignment 2, the second task, we are using back the same circuit that you have designed earlier. Just remember the 3 LED, but this time we are no longer using the code that you write. We are using micro COS2. Okay, it's exactly the same thing. Okay, the same work, the same design, but you're using micro COS2 on your lab assignment 1. If you're using ESP32, you're using FreeRTOS. So you pick one. Of course, this one we do simulation because you don't have the hardware. This one will perform the hardware on it. Okay, so this is for lab assignment 2. And the date of submission is already stated here. So basically, we do exactly the same thing, same design as what I mentioned earlier. This one, we are using back this design, same, but this round we are doing for what? For we are using real-time operating system. Okay, that's, you know, that's a reason I asked you these 3 tasks is separated. They are not related one another. So that's why we can using task 1, task 2, and task 3. So that's why you can using real-time operating system to control these 3 tasks. For your information, using real-time operating system is 10 times easier than the first assignment. Okay, trust me. All your senior can finish this assignment within a day. Some can finish within half a day. Okay, of course, it depends how you understand real-time operating system, but it's not difficult at all. Okay, so again, these are the marking scheme for your lab 2, the real-time operating system. Okay, clear? So again, I'm allowed you to have 2 in a group or individual in a group. So finally, the main assignment. So this carry the most mark. Okay. So again, it's up to you whether you choose ESP32 or PIC24. Okay. However, if you choose PIC24, cloud, okay, cloud program, I mean, you want to do IoT is a bit difficult. Why? Because PIC24 normally we type it, what I call that, ESP8266, okay? So, but it also possible, you type PIC24 to ESP32, okay? But there's a lot of work involved inside, okay? The problem is because we do not have a group work, so I try to be lenient, you know, in this main assignment, okay? Yes, any message? Sir, you say each module is separate, so means we call each. No, it's a separate means they don't relate one another. They don't affect one another. Okay, it's the same program, but they don't affect one another. That means when you're running LED 1, it wouldn't affect LED 2 or LED 3. Okay, is it all right? So do we need to include the result for task 1? No need. So you do not need. Okay, so I will give you all the answer for task 1. So it's whether you are hardworking, I don't know, I let you try at home, okay? Group and individual got different expectation. Okay, Ying Hao, for me, I will conduct an individual Viva. Okay, so it's the same, whether it's group or individual, but of course, I expect a little bit more, you know, I mean, no, I think it's the same because you are distance. You know, you are not work as a team. I'm not sure how you conduct the discussions. Okay, so for me, I'm fine with anything. Okay, so if can't use intro, how LED can blink constantly at 1 Hz using timer. Okay, I'm using delay. Okay, you think about that. So that's the reason I don't want you to try use time interrupt. Okay. So that's why I know that you use interrupt. A lot of people try to use interrupt. It's up to you lah. I'll open. You can use interrupt. Okay. So, but I prefer, you know, let's try something challenging, you know, without interrupt. How you solve this problem? Okay. So it's up to you, Ginseng. If you want to interrupt, you can use interrupt. Okay. It's all up to you. Okay. So let's look at the main assignment. What is the main assignment? Okay, so the main assignment is just something like this. Again, main assignment also can be done fully on simulation if you are using PIC24. If you're using ESP32, then there's no simulation. You have to construct a hardware. So basically, it's just a very straightforward and very simple. Okay. So that's the reason I asked you to buy DHT11 or LM35. Okay, let's have a look on this. So the fundamental, you just need a keypad, you just need an LCD, you just need a PIC24. Okay? Okay. So if you're using ESP32, the keypad or LCD is optional. You can spot the temperature and just display in any cloud platform you do. It's all up to you. I open this to all of you how innovative you are. Okay. So this basically is we are creating a logging system to monitoring poultry production. Okay, whether it's a pig farm, whether it's cow farm, whether it's a chicken farm, anything. So it's very simple. Okay. So a system is required to monitor and log the temperature of the machine subject over 12 hours period. The temperature sensed by a small temperature sensor M35 at DHT11. Okay. System that placed near the machine and amplify to produce a voltage of range 0 to 5 volt. Again, this is 0 to 5 volt is optional. We forget about this. Probably 3.3 volt also. This is nothing. This is, I put a star here. So this is just an example. If you're using PIC ESP32 or using PIC24, it's a 3.3 volt. So 3.3 volt is equivalent to 50 Celsius. It depends on application. So it's 0 until 50 Celsius. And this 50 Celsius also optional. Okay. So whether you want to measure the machine or whether you want to measure the poultry farm environment is all up to you. So it's not necessary to be 50 Celsius. It can be any value. Okay. or it's not necessary to be start from 0 degrees Celsius. Let's say if you want to measure the environment temperature in a chicken farm, normally it can be start from 80 Celsius. I don't know lah, Malaysia don't even have 80 Celsius. Probably the poultry farm is aircon until max is 40 Celsius already a lot. Okay, it's up to you. If you talk about machine, it wouldn't start from 0 Celsius. Probably machine will start from 30 Celsius until 800 Celsius or something like that. It's up to you. You know, the application is flexible. Okay, yeah, any question? Junki said, is keypad necessary? Again, I say if you're using Proteus, keypad is necessary. Okay, keypad is necessary. Probably you key in a password or something like that. It's up to you. Class, again, I know that you don't have a hardware. That's the reason I make it flexible. So in the end, I will ensure that you have some of the elements inside, like LCD, you know, PIC24. You're able to lock the temperature and store into the EEPROM. Okay. Some store in the internal EEPROM. Some store in the I2C EEPROM. Some store in the SPI EEPROM. Some store in the micro SD card. Okay. Some store in the hard disk. Some store in the cloud. Okay. At the same time, also store inside the internal EEPROM. There's a lot of way of doing this, you know. There's a lot of way of doing this. Is it okay, class? Okay. So it's all flexible. Not necessarily follow this over here. Is probably here is quite rigid. So it's all up to you how you want to design, you know, this, you know, because due to the COVID-19, you cannot go back to the lab. You cannot work as a team. So that's the reason I open it, you know. It's everything become flexible. So if you think that, oh, I want to use ESP32 to log the data, it's the time to try it. But of course, I will teach you all this, okay? So this is the optional. You Wi-Fi, store into cloud, all these things, you know, transfer. All this thing is optional. It's just optional. Last time got IS232, you know, it's all optional, okay? So the most important thing is this. You're able to display things into the LCD. If you're using PIC24, if you're not using PIC24, you're able to display all your visualization into a cloud or into any platform, you know, like ThinkSpeed. Okay, you can display the graph in a ThinkSpeed for analysis. So it's up to you how you carry on the design. But be frank, using ESP32 is much easier compared to using PIC24. But you're using PIC24, you learn more programming, you know, a lot more programming will be involved. So it's up to you how you want to do it. And some super hardworking, sir, can I use both? Yes, it's up to you. Okay, you want to do one in ESP32, you want to do one in PIC24, it's up to you. Even though you can merge these two things together, PIC24 it add as the computer, and just this ESP32 just add as the Wi-Fi module. It's all up to you. Okay. So here are some of the things, you know, add features. Okay, you are no longer advised. Okay, this is optional. I give this all optional, you know, optional because you do not have time to gather together. So the stepper motor is all these are optional. All these things is optional. Okay, it's all optional. So what I want is just LCD, keypad, and able to store the data and able to log the data to the EEPROM or to the I2C memory. Okay, so I will teach you I2C, I will teach you SPI. Okay, so it's not difficult at all. Okay, so then you're able to do all these things. Okay, is it all right, class? Okay, so I already give a plan. Okay, so these are some of the modules to guide you through. Okay, these are the modules to guide you through. The red color, you know, is optional. It cannot be done. I cannot check an LCD connection. The LCD connection can just done by the Proteus simulation. So start from week 5, you already start to create your system specification, planning, and creating your architecture. So I hope everything can be done by week 12 if possible. So you do a bit by bit. Don't do everything towards the end. So you don't have time. Why? Because a lot of assignment, a lot of things is coming in. I don't want to waste too much time over here. So to share with you, 4 years ago, students are so into this project, they're going to skip Dr. Lai Anzhao class, and until Dr. Lai Anzhao kicked my lab door and came into my lab and argue with me while this pointing finger to the students, and worse is the student is a final year project student. Okay, I don't want this, happen. Okay, of course now we don't have a situation kicking door lah. Okay, so because everything is online, so everything is over here. Documentation is until week 12. Okay, so I give you a proper planning. So here are the marking scheme. So every week I give you point when you report to show me that you're doing things, your group. Okay, I put 2 in the group. Okay. So here are all the comprehensive marking scheme to report, innovation, how I give marks. Okay, so this is during the Viva, all your interfacing. You see, I just give a display keypad, it's just a very simple. This is for Proteus. So if for ESP32, I put N, O, I put all here, I should put all here, not N. Okay, so I give mark to you based on your effort. Okay. So, and this is a Q&A, their presentation. This is a final marks. Okay. So this is the guideline of how to write a proper report. Okay. So, and then this is the, what I call that, the cover page. Okay. And sample report is over here towards the end. Okay. Class, any questions that you are not sure? Is it very stressful? Yes, any questions from the floor? Okay, relax. Seng Chen and Man Seng. I'm very flexible. Okay, it's very flexible. Okay, it's very flexible. I make it flexible. Okay. So, okay, any questions that you are not sure? Yes, got presentation. Definitely, we need a presentation for this because they got marks. You've got a Viva, yes, you need a presentation. So any questions regarding to these 3 assignment using team? Yes, of course, using team. Yeah, I want you to switch on I want to see your face, So I don't want, like sound, I want you to switch on this. I want to see your handsome face. Okay, no webcam. You can using your handphone handphone got camera. Lim Yi Chuan, don't lie to me. No phone. Okay, it's impossible. Okay. No, I don't believe you. Okay. Any other questions? Then Lim Yi Chuan come back to Utah to present. I believe that after August, after the government announced, I think everything is coming back to normal. Let's see, using S20. Okay. Yes, any questions? So any questions? You can record it as well if you want to present in front of me. Okay, any questions, class, regarding to this beautiful 3 different assignment? Okay. So now this one we will kickstart in week 5, do a little bit by a bit. Okay. So I know that I already told you early in the first week, this subject is a bit heavy. Okay, so I try my best to reduce the content. Okay, but to be frank, you will be learned a lot of things related to embedded system design. You learn about something on IoT, but for information, IoT is not difficult at all because you got so many libraries to be called. Okay, so it's up to you. You work in a group, you discuss in a group. So let's say, for example, this assignment, I want 4 in the group. Yes, you can. You may discuss with me if you want. You really got 4 in the group. Be able to work, as a team. Okay, so. My mouse shaking. Where got shaking, Kai Chin? You still need to present your FYP1 and FYP2 live. Okay, you better shake now, than shake later, in FIP1, Okay, so any questions? Okay, any question from the floor? If no, we still got 5 minutes. So within these 5 minutes, we just have some introduction. I know that you're all very tired already. Okay, it's just a very brief, relaxed introduction. So these are the microcontroller, fundamental microcontroller. Okay, we'll cover all these already. Okay, like example, why cannot? You see, you already learned under your microprocessor and microcontroller under Francis. You know all these things already. Okay, we'll touch this, we might touch this, we touch this, we touch this. Okay, we touch this. Okay, so in details. Okay, so those 10 microcontroller, they got all these features. You already know most of it. I'm not going through this slide. Okay, AT89X252 and AT89X253 is all under Atmel. Okay, Atmel is the very popular microcontroller those days. I put this thing here. They say 8-bit microcontroller are dying. Yes, it's dying. The market is not many market is using AT89X252, even ATX9253, but it's still in production. Some small companies, some old machines, is still in use. You say it's obsolete in the coming 20 years. The answer is no. Okay, even though the booming of 32-bit or 64-bit, like ARM microcontroller, IoT come into play, but still, even though you design any small scale machine, you don't need a very high scale microcontroller. Okay, you don't believe me? You can go to any things. You just click Ignite-S8253 example. Okay, then you click the production. Okay, and it's not cheap, 11 ringgit. Okay, it's still under microchip. No more Atmel. Atmel already dying. Okay, they are replacing, because it's bought over. It's still in production. Okay, so how much is it? Just now I saw 11 ringgit. And like this one, 21 ringgit. I say I better go and buy ESP32 development board. Correct. I better go and buy ESP8266 development board. So powerful. Correct or not? Am I right? I better get my Uno board. Okay, because this is just a cheap nothing, no crystal, nothing. It's already cost about 11 to. Some more advanced one is 8-bit, 21 ringgit. But for your information, it's still in use in the industry. Don't say they are dying. Yes, probably in coming 20, 30 years. But you ask me, ESP8266, is it dying? I can tell you, yes, it's dying. ESP8266, because ESP32 newer version is released, the design actually is to kill the ESP8266. Because ESP32 and ESP8266, the price is not much different. Okay, so the more complex X0C517 is just the input-output port. So that's why I say input-output port is very, very, very important. You cannot simply connect all the input-output port as you like. Okay, so what is important? Timer is important. Interrupt is important. So if you use all the external interrupt, then you got other more important interrupt, no place to use. Okay, you got what I mean or not? Let's say, for example, PIC24 got 2 external interrupt. If you're doing my 3 switches down there, then you you got 3 switches. My assignment 1, these 3 switches use up all the external interrupt. Then I want to have a sensor, external sensor 1, external sensor 2, which is more important. No place to put in. Correct. If I want to use the interrupt. So that's why interrupt, timer, all these things is very important, especially external interrupt and the input output bit. Okay. So of course, market is booming. That's why ARM is coming into the market. Why? Because a lot of microcontroller at that time don't have floating point processor, don't have DSP processor. You need to separate it when you do floating point calculations. Is not efficient at all for the 89X8252 for a big 18 or big 30, big 24 is not efficient at all. So that's why for a more comprehensive and more powerful microcontroller, we are looking into the ARM market. So all like, for example, CloudVision support all the ARM market. Okay, it's 6 o'clock already. Okay, somebody already angry to me, with me. Okay, we can configure Snapdragon. Okay, bye-bye, Ding Hui. Okay, thank you for joining. I think that's all for today. I will stop recording already. Okay, so, okay, while I'm still here answering your question, why this